All right, so scatter plots, which are nothing like connected dots, you guys.
But it looks like it.
All right, but it's not.
What is?
All right, so I want you to make a scatter plot.
Just
All right, so how do we make a scatter plot?
Put down 3.
All right, so let's make a scatter plot. So what I want you to do is draw a little bit, as best you can, a Y line, which is straight up and down,
How many?
and an X line. So draw that, please.
How many?
I just want you to draw that.
Okay.
All right? Okay, in fact, I am going to cheat a little bit.
Looks like we could.
There was a spider. I panicked.
Oh,
But I think it's
didn't let me
gone
do it.
now.
But- oh, that's why. All right, so I'm not going to worry about it. All right, so here's your plot. You can stop talking. That would be great. Because now you're being rude in the internet. All right. So what I want you to do is you're going to have a lot more points on the y-axis than you are on the x. So go up to 20.
Can I go up by tens?
Am I going up by 10s?
You go on the x-axis.
I'm going on the y first. And I went up to 20. And on the x, I'm going to go up to 10. Well, I went up to 15. Go up to 10. All right. So what I want you to do is I want you to graph these points. So look at the chart that's on page 538, and I ask you to graph these points. So number of laps compared to the time. So your x is your number of laps, and your y is your time. So if they did 3 laps in 9 minutes, where does that show up?
Wait till us. The Y is 10.
Y is time.
Okay.
3 laps in 9 minutes. This other person did 4 laps in 8 minutes.
Oh, I see.
Okay? And then 2 laps in 3 minutes. So you're kind of filling in a whole bunch of stuff that you can't, as someone said, you can't connect the dots on these. If we were using actual graph paper, it would be a little more accurate, but you don't always have graph paper, and you can make these without. All right, so you end up with a scatter plot.
Does that mean like some can be in the same line as just?
All right, if you're looking at your scatter plot that you made or that you're making, if you take a look at that, we know all those points don't lie on a straight line. But if you look at them, can you draw a line that passes near almost all of the points? Yeah, you could. In fact, if you look at the book, it shows you one, but you could. That means we can correlate all these numbers, the number of laps completed and the total time. So we follow the line above that's drawn, we see that as the number of laps increase, the total time increases. So if we were to draw a line showing this, we would pass through something like that. And I'm a little off because I bent it a little bit when I made it. And many of those points fall near that line. Anyway, the term for that line is called a best fit line. What line fits most of the points? It's called a best fit line. Because it best fits all of them. One of those points is furthest from the line. Which one do you think that one is?
The
The
415.
The 6, 7.
The
That one.
515.
Yeah. Okay.
Oh, yeah.
That's the furthest from the line. It's an outlier. Not every point is going to be close to the line. Yes, that other one, the one that you mentioned, the 415 one, that's kind of far out too. But 6, 7 is the furthest one from the line. But
So how do we know when we're doing this what angle it should be for the line? Like,
it's what line can you draw that's going to best touch almost all the points.
okay, so
Okay?
Straight up and
it
down.
doesn't
Okay.
have to be. It really only touches one of them.
It touches one, but look how it gets close to the majority of them, right?
It touches two of them.
All right, that one hits the majority of them, and that's the one. In fact, 3 of them are really almost on the line. One of them for sure is. All right, so 3, 4 of them. Let's see, on the line I drew, 1, 2,
It would've
3,
hit
4,
3.
5 are almost on it. So now, can we make an equation for that line? That's the tough part.
Probably.
Can we make an equation for that line?
Yes.
Okay, we have to estimate the slope of the line.
We have to make the triangle.
So we make a triangle. So best place to start the triangle is where it actually touches the dot, right here. Okay? Now this is going to work best in graph paper.
Yeah.
All right? We know the y-intercept is always going to be 0.
It's 4 over 2.
So where would be the best place to do that?
Isn't it? Yeah. That's good. Okay, go.
Oh, but yeah, you can reduce it to 5 or 2.
So it's 2 over 1. 2.
Where do you think it's going to be? So here's my triangle. So now we got to think about this one. And I want you to think about it closely. Where do you think it would best be to make our triangle?
Go down.
Yeah.
If you went down?
Yeah. Because if you.
Okay, so if we went down from that point, what's our slope? Rise over run.
What if you 4 over or 8 over 4?
This is
7
7
over
up,
4.
Oh.
and this is 3 over.
7 over.
It's
7
3 over.
3.
It's 3 over. I wrote
So
my
7
graph.
over 3.
So your equation would be y equals 7/3 x,
Oh, okay.
right?
Right.
C.
So your equation is 7/3 x. Using that equation, we can figure out some information. How long would it take you on average based on that graph to run 7 laps?
So we have to
Would
turn that into.
Okay, so if you replace x with the number 7.
So then
7 equals 7 over 3x. So 7 times 7, 7 times 3.
So
49 over 21.
49 over 3. 7 over 1, right?
Wait, so we have to times it by, oh.
So if you did 7 over 3 times 7 over 1,
Where did we get?
15 minutes.
I plugged it in with 7.
You get
I take-
16 and 1/3.
Okay, so about 16 minutes, right?
Oh, yeah.
If we rounded it.
Yeah, 16.
Where do we get 7? I just said, how long would it take you to run 7 laps?
Mhm.
So I'll plug 7 in for x.
Yeah.
So 7 minutes per, or 7 minutes. per
Yep.
or-
Yep. Does that make sense?
So basically, if you ran 1 lap,
It would take you
it would
1
take
minute.
you 7 minutes. right?
Roughly. Okay, does that make sense though?
Yeah.
All right?
I know.
It is a long time.
What kind of lap is
Well, we
that?
didn't say how long the lap was. No.
Okay.
We did 5.
I said
Well,
7
yeah,
laps.
I'm
I said 7 laps. So
Yeah.
that's just a little over 2 minutes a lap.
Oh,
yeah.
So I said 7 laps.
That makes more sense.
Does that make more
A
sense?
7-minute lap? What the heck?
No, it's not a 7-minute
kind of
lap.
horse
We had to do a 2 mile.
All right.
What kind of horse are they?
Course.
Now,
Oh, it's a horse.
now when you make scatter plots, if you look at the bottom of page 540, if you make scatter plots, there's some things you can come up with. Look at that first graph on the very bottom, page 540.
Looks like a hand sign.
Okay, that one you can see a line that you can imagine being drawn into that, right?
Mhm.
That's positive, because it's going up.
Okay,
The second one, they're all going down.
so it's negative.
That's negative. You could picture a line coming up from the top going down, right? That's
Next one looks
negative.
like the stars.
The next one, they're all over the place.
It's like Mario's.
Almost looks like a giant claw slashing.
Or-
They're all over the place, right? That one, you could not imagine a line being drawn into that, so that one would not work. You could not create a scatter plot for that.
It almost looks like a guy.
Okay, so keep that in mind as well. Now we're going to skip part of this, but what I want you to do for today is your assignment. Hold on, Joe. Your assignment is to do number 8. So turn to page 543. Okay, I want you to do number 8. So I want you to do this on graph paper, but you need to replace the numbers. So number 8 says, Freddie ran for 8 minutes wearing a heart rate monitor. He checked his pulse at every minute of his run. Freddie's heart rate at each minute is charted below. All right, so always the first column is your X, and the second column is always your Y.
Could we do for the heart rate, could we do it by 5s? Because going up
I-
to like
No, because
Well,
it's 3.
my-
There's
my-
1, 2, 3.
My first thing I would do is I would not start at 0.
Oh, yeah.
I would start at,
120?
no, I'd start at 90.
Oh, yeah.
I wouldn't start at 95, but I'd start at 90.
Wait, first column is X.
First column, X is the first column, and the second column is Y.
So X equals something over times.
All right? Does that make sense so far?
Mhm.
So what I want you to do is to draw the graph and make the scatter plot. Does that make sense?
Yeah.
And then number 9. And it's going to ask you a question about the graph you make. Number 9, Shayna conducted a survey to find out how much money her customers are willing to pay for a new item. She charted the number of people willing to buy the item for each proposed price. Okay, so again, the first column is,
X.
and the second column is.
Y.
Okay, so make a graph. Is this a positive correlation or negative, and then draw a best fit line? You did not have to do that on number 8.
What?
You don't have to make an equation. You don't have to do any of that.
Just make the graph.
Just make the graph.
How would you do that though? Would
Then
you do
the-
like $1, $1.50, $2, $2.50?
Yeah,
and
you
then-
go by your X, you go
People?
by 50 cents, right? 50
Wait,
cents
so
across the
over
bottom.
would be the money?
Yeah, money is over, because the first
yeah.
column is always X. The second column is always Y. Okay, so
Wait,
if,
so wouldn't it just be tons of dots in the same place?
that's what you're gonna look at.
So dot, 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 like in a really tight circle? think that's